Hello friends, myself R.D. Mahajan presenting my one more video on Newton-Raphson method. Let us see the example. Find by Newton-Raphson method the real root of the equation cos x plus 1 is equal to 3x, correct up to 4 decimal places. And as we required answer in 4 decimal places, fix your calci for 4 digits only. And then cos x plus 1 is equal to 3x, containing trigonometric term of cos x, and as it contains trigonometric term, we have to perform the calculation in radian mode only, and therefore change that mode to radian, and therefore transferring this to other side, we get that equation as 3x minus cos x minus 1 equal to 0. From this we find f of x as 3x minus cos x minus 1. Then differentiating it with respect to x, we get derivative of 3x as 3, differentiation of cos as minus, and this minus it becomes plus sine of x, and derivative of 1 is 0. Okay, and therefore it is 3 plus sine x. And then by trial and error method, we require to obtain two initial guess values such that for opposite sign, and therefore for x is equal to 0, we get f of 0 as, substituting that x as 0 here, we get 0 minus cos 0 and minus 1. And by calci, the value of cos 0 is 1, therefore it is minus 1 minus 1, we get that value as minus 2, which is less than 0, negative value. Then we require to find another value for which function is with positive sign, and therefore we check for x is equal to 1, f of 1 is equal to, here it is 3 into 1, that is 3, minus cos of 1 and minus 1. And by calci, it's 1.4597, positive 1. And therefore, as one is with negative sign, another with positive sign, that is, root lies between x is equal to 0 and x is equal to 1. And out of these two, we have to consider one as a x0 initial guess value, and the way to consider is check the corresponding function value. For 0 we have minus 2, the distance from origin is 2, and for x is equal to 1, it is 1.4597, its distance is 1.4597, and therefore this distance is less than this distance, and therefore the corresponding value of x we consider as x0, therefore let x0 is equals to 1, and then by applying Newton-Raphson method, first iteration, we have x1 is equal to x0 minus f of x0 by f dash of x0. Newton-Raphson formula using this. Substituting the values corresponding, x0 is 1 minus corresponding f of x0, for x is equal to 1 we have 1.4597 whole divided by f dash. Substitute that here in this, so that we get f dash of x1 is 1, x is 1, and therefore we have 3 plus sine 1. F dash of 1 as 3 plus sine 1, and by calci that value is 3.8415. Substituting here in this formula, 1 minus 1.4597 divided by 3.8415, and if we perform this calculation by calci, the corresponding value we have 0.6200 as the first approximation for the root, and then we check it whether this gives the root or not by finding the function value at that point. Therefore, f at x1, it is 3x, 3 into 0.62 minus cos of 0.62 and minus 1, 0.0461. If it is equals to 0, means first 3 digits after decimal point are 0, then we can stop the iterative procedure. Otherwise, we have to continue. This one is not equals to 0. We have to go to the next step, iteration number 2. Then in step number 2, we have to obtain the value of x2 as x1 minus f of x0 by f dash of x0. Where the value of x1 is 0.6200, corresponding function value is 0.0461, and f dash of x1, substituting x is equal to 0.62 in this, we have 3 plus sign of 0.62, and by calci we have the value as 3.5814, performing all the calculation in radian mode only. And therefore, substituting that value here in this, we get x2 is equal to, x1 is 0.6200, means 0.6200 minus f of x0, it is 0.0461, and by calci its value is 0.6071. Once again we check it whether this is the root or not by finding the corresponding value of the function. Therefore, f at x2, when substituting that value here in this, we get 3 into 0.6071 minus cos of 0.6071 and minus 1. And if you simplify, or if you try to get its value by 0.0000, exactly equals to 0, and as its value is exactly 0, we stop the iterative procedure, and therefore approximate value of the root, approximate value of the root is this one, 0.6071. This is the real root of this equation by applying Newton-Raphson method or Newton-Raphson technique. And then once again the step required or iteration required only 2. In 2 steps only we are able to get a required root. Therefore, this is the required answer or required root. One more I will discuss in my next video. Therefore, if you are watching my videos, please like, share it, as well as subscribe to my channel to get other notification for the new videos. Thank you.